Question 1. You want to make 3 gallons of lemonade for your little brother's lemonade stand. After experimenting with different mixtures, you've determined that a 40% concentration of lemon juice in water has the best taste. Hopefully you added a little sugar. You have a large supply of 25% solution and 50% solution. But how many gallons of the 25% solution are you going to need to combine with the 50% solution to get your 3 gallons of 40% solution? And we're going to write our answer in gallons. Boy, that's a lot of information. What we're going to do is go back to an example that's going to help us solve this problem. Now, going back to our lemonade problem, we're going to set it up quite similarly. We're going to use our A plus B, but now instead of 13, we know that we wanted 3 gallons of lemonade. So that's our one about the quantity or amount of lemonade that we're going to make. The next one is about the percent of the solutions. And we had a 25% and a 50%, and they resulted in a 40%. So I'm going to put my 40% last here. Might be a good idea, because my decimal's hard to read, to emphasize that with maybe parentheses, because we have to multiply that, remember, by our 3 gallons. We have 3 gallons of a 40% solution, of meaning times. And now we have some unknown amount of a 25% solution plus some unknown amount of a 50% solution, and together they're going to make 3 gallons of a 40% solution. So again, I'm going to substitute, but this time I'm only asked to give one of the answers, so I want to be careful that I go straight to that answer. Since I'm asked about the one that we chose to make A, okay, we were asked how many gallons of the 25% solution, so really we're solving for A, then we want to go ahead and set it up where we'll find A. So we're actually going to solve up here for B, and say that B is 3 minus A, so that when we substitute, we're substituting in for B and solving for A. So we have 0.25A plus now 0.5 or 0.50. You don't need the period, the 0 after that. And then it's the quantity 3 minus A, because that's what we're substituting for B, equals, and we can go ahead and multiply our 3 times the 0.4 now and get 1.2 to kind of get some steps in there. I'm sorry, my decimals aren't showing up really well. Now, our next step, because of order of operations, requires us to distribute and get rid of those parentheses. So we're going to have our 0.25A plus 3 times 0.5 is 1.5 or 1.5, minus, because there's a negative A, and then it's going to be 0.5A equals 1.2. Now again, like terms are our A's, so 0.25 minus 0.5 is going to create a negative 0.25, and that might worried me a little bit, because I'm like, how am I going to have a negative quantity? But you'll see that in the end, the negative is going to go away, because we're now going to take our 1.5 away from our 1.2, making, again, a negative, but you're going to see now it's going to make negative 0.3, okay? But then when we do our division, we have to divide both sides by the negative 0.25. Negative divided by negative is positive. So when I divide negative 0.3 by negative 0.25, and you may have to go do some side work to see that, you will get a positive 1.2. Then we have to remember what that meant. Remember, initially that meant that A was my 25% solution, and they asked me how many gallons of a 25% solution. So this is 1.2 gallons. So they didn't ask for what B would be, but if you wanted to know, you would substitute 1.2 back in for A up here. And it'd be 1.2 plus something makes 3. So you would take the 1.2 away from the 3, and then you would know that B is 1.8. Because 1.2 and 1.8 make 3. So that would be our gallons. So in the end, we would need 1.2 gallons of a 25% solution of lemonade in order to create our 3 gallons of 40% solution. This is a challenge application problem. That ought to give you a clue that it's going to be a little bit more challenging. And it falls under the broad category of chemical mixture, weighted average. You also see coin problems at these kind of problems. And they also are listed in problems that land in systems of equations. The reason it lands in systems of equations is because we have 2 variables, and that means we're going to need 2 equations or a system of equations to get an answer. And just so you know, if there were 3 variables, it would take 3. If there were 4, it would take 4 equations. You need as many equations as you have variables to come up with a solution. In this particular case, our problem writer has decided that they're going to call the 17% mixture of antifreeze in this problem A, and the 43% mixture B. Now normally antifreeze and lemonade aren't a good exchange, but they behave the same way in this problem, so we're just using percent solutions. So if we have some A and we have some B and we mix them together, we want to get our 3rd item here. Now, it would seem like this might be C, except that they've told us we want 13 gallons, so we know that one. So we only have 2 variables. How much of A plus how much of B will make 13? All right, but we need a second equation according to the rule, and that would be an equation that's about these percents. Remember, at first we were talking about the amount of the mixture. Now we're talking about the amount of antifreeze in the mixture. So it's kind of unfortunate they use the word amount twice. This is quantity like volume, and this amount is really the concentration of the antifreeze. So that's our percent numbers down here in the example. So our second equation tells us that no matter how much quantity-wise we have of our 17% solution, we can multiply it by the quantity times the 17, and we'll get that answer. So we can say that 0.17 means the same as 17%, and then we say that 0.43 is the same as 43%, and together they're going to make 32%, but we know they're going to make 13 gallons of 32%. And if you hear that word of in there, that of means times. That's why A times 17 works and B times 43. Of means times in a word problem. So we have our 2 equations. How do we solve them? First, we remember that we learned how to do substitution and elimination in a previous lesson. This problem lends itself nicely to substitution because we can easily get a value for A or B and substitute it into the other equation. So they did this by taking B away from both sides and coming up with A equals 13 minus B. Then they substituted the 13 minus B anywhere they saw A in the equation. And you can see that now the A has turned into 13 minus B. They used parentheses and even a dot to emphasize that this is now multiplication and you're going to distribute. So they wanted to be sure you know that really you're going to multiply 2 times. So it's going to be this times that one and then by that as well. So that's why below it creates 2 answers, 17 times 13 and 0.17 times 13 and 0.17 times our negative B. So that's where those 2 come from. Once you've done the distributing here, over here you're going to do the multiplication and get 4.16. Here you do the multiplication of the 13 times the 0.17 and get 2.21. Then we're looking at our 2 like terms, our B's. When we combine 0.43 and negative 0.17, we get 0.26. Now we're going to take 2.21 away from the 4.16, giving us 1.95. And then we're going to divide by our 0.26 and eventually get our answer. Now you, of course, can stop and study that if you're having difficulty following the adding, the subtracting, and the decimals. I'm mostly wanting to emphasize the setup of the problem. Once we've solved for b, we have to go say, what do we do with that? Well, it's much easier to go back and put it into our first equation and find out that we then have 5.5 for a. Then we have to remember that that was the gallons that we were looking for of the percent solutions. So in this case, they wanted to know both, so our answer has to include both, and they have to be clearly labeled with which was which.